Hello everyone, my name is Ifra Idris. I'm a third year PhD candidate at Brown University, and today I will be presenting my research under Dr. Stephanie Telix on towards conversational interfaces and visual memory representation for social robots helping the elderly. The problem that we are trying to solve is how can we advance user facing systems and interfaces for autonomous social robots to help the elderly in their activities of daily living. We believe that social robots have the potential to help the elderly, provided that they can obtain enough situational awareness and can build a rapport with their human partner. In the past, there have been a lot of context aware social robots that have been able to gather information about the elderly's activity and also about the objects in the environment. But they lacked a natural conversational interface and a long term memory representation for visual perception to support all these long term extended interactions. So, the solution that we are proposing is actually a joint framework that supports both the understanding of the spatial environment and the multimodal behavior of the elderly. And based on this understanding, is also able to carry out conversations with the elderly to help them meet their needs in daily life. In this paper, we are actually providing two proof of concept demonstrations for two use cases, and these are separate demonstrations. The very first demonstration is for a robot actually helping the elderly to find household objects that they might have hard time remembering. And this can span not just weeks, months, but even years. For more detailed overall high level architecture that we present or use for our prototype, please refer to our paper that is cited over here. And as you can see, our prototype RoboMem is able to make an efficient queryable representation of a 2.5D environment where it can answer queries such as where was the pink cup. Our second demonstration is of a robot actually engaging in a dialogue to guide the person through a cooking recipe. To know more details of our prototype for our initial implementation of prototype, please refer to the cited paper, and please scan the QR code to be directed to a full demonstration of our robot, our dialogue manager deployed on a robot. On the left, I actually show you a sample dialogue where for a particular step, if Curry believes that it is necessary for the activity to be tracked or monitored because it might not be safe for the elderly to do it on its own, it says as follows. For which, if the elderly actually shows some resistance, it actually presses on the matter that it will be better if you let me monitor the activity because it will help us in completing that activity safely. And then once the elderly is on board, it actually carries on the rest of the dialogue conversation and is also able to infer based on the sensory input, stating that the step has been completed safely. Our dialogue manager is a planning based finite state machines that takes the decision for the next dialogue based on the current user input, on the binary sensory input, as well as the dialogue history. So once we did a system evaluation of our prototype, it showed real-time performance, but there were errors. When looking at the dialogue manager prototype, there were errors because of speech recognition, because of intent classification, and because of action policy. While if we look at our object retrieval RoboMem prototype, there were errors because of object detection. But along with this, there are other things to consider for long-term deployment of social robots. We need to consider that how much comfortable will a human be with a robot patrolling their house. We need to consider what social behavior should be added to a robot. We need to consider that how much of a role is a robot going to play in this master-slave dialogue paradigm, or should it be more collaborative, especially when we are trying to help the elderlies with dementia. So, in summary, we actually present a joint framework that supports both the understanding of the spatial environment and multimodal behavior of the elderly. And based on this understanding, is actually able to carry out conversations with them to help meet their needs in daily life. This paper actually provides separate proof of concept demonstrations of two use cases of autonomous social robots helping the elderly in their home. Thank you for your time, and now we are open for questions.